So as Dr. Mittal mentioned, I have spent a lot of time in the industry. I have worked with many global organizations and have got good exposure in big companies, held good positions and achieved quite a lot of global exposure also. But you know what I would like to say here, you can check my profile on LinkedIn by my name. My name is, I will spell out my name shortly. But you know, the greatest thing about me, and that's what I'm excited about today as I come to talk to you all, is that I have been very fortunate that when I entered the industry, in the information technology industry was at its inception. It was just starting. And when I left the industry of as I am now towards the end of my career, now it has evolved into the digital age. So I have seen that entire evolution, and that's what I'm going to be talking about today. How this entire the technology segment has evolved over the years. Can I request you all kindly to keep your laptops on?
Sir, you are being muted.
Sir, you are muted.
Ashish sir, you are on mute.
Okay, I'm very sorry. I think I don't know how that happened. So am I audible now?
Yes, sir.
Okay, so I'll repeat what I was saying. As I was saying, I don't want to spend a lot of time in introducing myself. You can check out my profile on LinkedIn. But I've spent about 35 years in the industry. I have worked with a lot of global corporations and have been fortunate to get good exposure worldwide on many different parts of the technology. But the most fortunate thing about my profession and about my career, which is what we are going to be discussing today, which will help me in what we are talking today, is that I have been able to witness the growth of information technology right from its inception, when it was in its very early days, up to today, when we are in the digital age. So the whole digital age evolution has been in different stages, which we'll be talking about today. Okay, so but in terms of my own introduction, I would not like to spend too much time because we do not have enough time today to talk about the many things that I have in mind. But just to give you a brief overview of how this series will grow, not only in this lecture, but so my lectures will be aimed at familiarizing you with the key concepts and uses of digital technologies and trends. And I aim to talk about how these trends evolved, as I was saying, the way they have transformed the world around us and their potential and scope in shaping your future, the future of the industry. You are the workforce of the future. You will be soon joining corporates or government service or startups or doing your own business in whatever field you go into. The one area that will touch you in whatever you do in your future is digital transformation. And this digital transformation is not something that is relevant only to people who are from the technology fields like electrical engineering or computer science, but to everybody, whether even if you are in civil engineering or in mechanical engineering or in aeronautics or chemical or whatever you are doing, you will not be working in the rest of your corporate life in an industry which is not touched by digital technology. So that is the reason that this course is extremely relevant for technologists like you all, and even for management people. So you are the corporate workforce of the future, and you go into that corporate workforce armed with knowledge of digital technology. In fact, I have visited a lot of IITs, the older IITs like Kanpur and Delhi and others, as in placements also for hiring people from IITs, and I've been fortunate to get some very good colleagues hired from many of the IITs. So I understand where the motivation is, where the orientation is, and what the future requirement is, and that is what I have used to shape these courses. And I understand, that here also amongst you, though we have not had a chance to get introduced, but my understanding is that we have people from different disciplines. So therefore, I will not be talking too much about technology alone, which would not make sense to everybody. And this is very normal. Whenever there is a talk of digital transformation or digital technology anywhere, There is always a mix of people, even in companies. It's not that everybody in any company that you go to tomorrow, suppose you go to work for a consulting company or a software company, not everybody is technical. So therefore, the digital technology has to be taught and conveyed in a manner that it makes sense to everyone, not just the technical people. Okay, so that is what I would like to. And one important thing that we will talk about digital transformation subsequently, but one important thing that I want you all to know and understand is that digital transformation is not an end in itself. I mean, you all know, like for example, like a caterpillar turns into a butterfly, right? So that's a transformation. The moment it becomes a butterfly, the transformation is complete. Digital transformation is not like that. Digital transformation is ongoing. Even very core digital companies like Amazon or Uber or Netflix or Google and all these companies, they are all still digitally transforming. You cannot wake up one fine morning and say my digital transformation is complete. It is a forever exercise. It is always ongoing. The technology is evolving every day. New models are coming in, new innovation is happening. So therefore, digital transformation is a never-ending process. Please bear that in mind. Digital transformation doesn't have a start and an end. Digital transformation is a journey. Remember that. That is very, very important to remember. And lastly, one thing I would like to say, I have a tendency to speak fast, so pardon me for that and bear with me. But do feel free to stop me when if I'm speaking something that is not making sense, or if you would like me to repeat something, or if you would like to ask a question, please feel free to start. I would love to make this as interactive as possible. I would also like to learn from your experiences, and if time permits, I would love to talk about some stories which would sort of exemplify or explain better the points that I'm going to be talking about. But I am not sure how much time we would have. So it's up to you to make this class interesting by drawing and sharing your own examples from your own life, because digital life has touched you all already. You are all born into the digital world. Unlike people like us who are old, you are all born into. So it's not that digital technology is something new, or the concept that I'm talking about today are something totally alien to you. You all use mobile phones. You all use digital cameras, digital TV. This Zoom call that we are having today. Just imagine this pandemic that we are going through today, unfortunate thing, this COVID. Suppose this has happened in 1985. What would you do as a student? There was no way that online classes could be held, or any major breakthrough could happen in any field. You would be just stuck. You would have lost a year probably. So it's thanks to digital technology that we have these concepts and applications like Zoom, Skype, and so many other applications which enable us to interact, even though we do not have to be physically in the same place. Unlike earlier, when we all had to be in a classroom in order for a class to happen. So this is also one of the boons of digital technology that we are experiencing as we speak right now. Okay, so let us begin now. I'm going to share my screen. I'm a little bit new with Zoom, so please bear with me. So any questions so far? This was just a basic outline. So we will begin with a quick overview of the evolution and adoption of ICT. I will talk about what is ICT, because ICT is what has resulted in the evolution of digital technology and digital transformation ultimately. So this is, as I said, quite familiar to you, much of it, and I hope it will be familiar, because if it is familiar, you will relate to it better. I don't want to talk about concepts which are very new or very complex. That's not my intent at all. I will talk about very simple things which you have already known. My intent here is not to teach you anything, but to awaken certain things and put them in context, how they are going to be relevant to you as you move forward with your lives into corporate careers or into businesses or government service or whatever you choose to do as you go forward. So any questions so far? Can we start now? I'm going to share the screen now, so I'll be sort of going out of the view, and is the screen visible?
Yes, sir.
Okay, so the subject today is ICT evolution and adoption. So the question is, anybody here knows what is ICT? When I've used this term 2 or 3 times, and that is the topic that we are going to be talking about today. But anybody knows what exactly is ICT? What is it? Okay, so let me. When I ask a question, I will wait for 5 seconds. If I don't get answers, then I will proceed, because I don't want to lose time. Time is very, very, very precious today. Okay, I'm sorry. Excuse me. ICT stands for Information and Communication Technology. You have all heard the term IT, haven't you? IT. People talk about
Yes.
IT this, IT that, information technology. But IT is an incomplete term when we talk about. Okay, so we were talking about this whole concept of ICT. So what we define today, the world around us, and whether you look at the devices, like for example, the mobile phone in your hand, or the internet, or all the other, the whole digital revolution, the so many different technologies that we see around us in the digital world, they are all products of ICT. Now, ICT, when we started ICT, it was in a very different way than what we see today, and that's what I want to talk about, the whole journey of ICT today. So we refer to ICT, let's just to define ICT again, to refresh that we refer to ICT as a kind of a common term to indicate information and communication technologies. Okay, so any information, anything that has to do with information technology, anything that has to do with communication, anything, whether it's a device, whether it's a software, whether it is a hardware, whether it is a network or anything, application, everything is ICT. Okay, so now the whole digital revolution is centered around ICT. So it is important to understand ICT before we move to digital technology. So that is what is the focus of today's discussion. In fact, this ICT is a very, very important concept. It is a widely and worldwide also, and it is used as also as a benchmark to measure the economic and social development of countries by the United Nations. So they say that a country which has a high ICT index has greater per capita income, it has more economic prosperity, higher literacy, more human progress. All these are defined by ICT. So if you define ICT index, high ICT index means an advanced country, low ICT index means a not so advanced country or a developing country. So that is the importance of ICT. The entire world looks at ICT as not only just as a measure of technology, but a measure of human progress also. Most of the Western countries rank very high on the ICT index, and some of the countries in, for example, Africa, they rank on the lower end of the ICT spectrum. So ICT is a very key concept today to define technology. It is and we will talk about what constitutes ICT. It's a critical factor in an understanding of which is crucial, especially for you folks here who will be joining the technical workforce of the future. Okay, so ICT is not the one thing that I want you to take away from this slide. Very important thing is that ICT is not only about computers. It is not just computers. IT may be about computers. ICT is not about computers. ICT is about hardware, software, communication, networking, the applications, everything, the whole gamut of things constitutes ICT. And as we go through this, hopefully this will become clearer. Now, one more concept that I want to introduce here is the concept of convergence. When two things converge, okay, when two different technologies converge to create a third technology, it is known as convergence. I'll give you some examples. For example, your mobile phone, not the smartphone, just take an ordinary mobile phone. It is a convergence of two separate technologies. If anybody wants to take a guess on what two technologies have converged to create the mobile phone, it is telephony. Some of you would have heard, would have studied about telephony, basic telephony, the earlier telephony, and radio. When telephony and radio converged with one another, they created the mobile phone technology, mobile technology. It is not a new technology. It is just a convergence of two existing technologies. Similarly, if you look at, for example, your IPTV today, you watch Netflix and other streaming videos, etc. on your IPTVs. Now, IPTV is a convergence of the traditional TV, which was the hardware, and the internet. So when both combine, when both converge, you get a third technology, which is IPTV. So there are hundreds and countless of examples. A laptop, for example. Laptop is a convergence of your different things, like, for example, your monitor, your keyboard, your CPU, your central processing unit of the computer. Everything converges into one compact unit called a laptop. So these are all examples of convergence. So convergence is a very critical thing to define the evolution of a new technology. Most of the new technologies, even if you see in the digital world, which we will study over the next few classes, if you take, for example, a cloud or social media or mobility or any other concept which we will be talking about, none of them is a new technology in themselves. They are all the result of convergence of different technologies. Another word for convergence is intersection. When two different technologies intersect, they create a third technology. Okay, so basically when we talk about ICT, it is a convergence of two different technologies. One is information technology and the other is communication technology. So these were two separate streams. If you look at 20 years ago or 30 years ago, communication was different. It consisted of telephone, telex, telegram, all that was communication. IT was different. All the computers, the desktop, the mini computers, the mainframe computers, all that was IT. They were not, teaching style may not be the best one, but I hope that I'm able to convey the key concepts that are required. So again, I would like to repeat that ICT is the very basis of the digital revolution. Without ICT, there would be no digital revolution. It's very simple as that. An understanding of digital transformation, which is the subject of this series of lectures, is incomplete without an understanding of the evolution and adoption of ICT. We'll be talking about adoption also, which is a very important concept. So let us move on in the interest of time. Ravi, if you would move to slide number 3. Are we on slide number 3? The heading is the ICT, the convergence that spawned a new world order.
Yeah.
Okay, so this is the convergence is what we just talked about. So much of the technical revolution that we see around us is a result of new technologies converging with the old. I'm repeating that because it is important. Tomorrow, a new technology may come through does not mean that it is some breakthrough new invention. It is just innovation, which has happened to bring different technologies together to create a third technology. I'll give you some examples. The smartphone, which we already talked about, the laptop computer, IPTV, voice over IP. All these are some familiar examples of convergence of IT and telecom world. Okay, when IT and telecom world converge with each other, these technologies emerge. ICT is the grandest convergence of all. It is a convergence of two huge domains, information and communication, each of which is a huge industry or a huge sector or a huge vertical in itself. So the convergence of information and communication domains to create a new ecosystem, which is what we will be talking about, which is the digital ecosystem. So I hope that the meaning of convergence is clear, because we may be referring to this term more often as we go forward in these series of lectures. Now again, ICT trends are evolving. Everything that you see today, for example, people talk about artificial intelligence and neural networks and all kind of new breakthrough kind of technologies. All that are also manifestations of ICT. It is nothing but ICT. So ICT is trending. ICT continues to evolve. So trends in ICT enable new developments in different industries. For example, in banking, or like you see in this slide, that the enablers of ICT are what you see in the center, the intersection of software, internet, telecom, networking, and hardware. Anything to do with any of this is ICT. And where they intersect, that is where you get magic happens, like digital or internet or all these things happen. So their intersection is important. Their convergence is important. When they come together, they create new systems, new technologies, new applications, new devices, and entirely new industries also. For example, the e-commerce industry was not there earlier. Now it is there because of ICT. Yes, banking was there even before ICT. But e-commerce is there only because of ICT. Even banking, the impact that ICT, look at the impact of software on banking, for example. Most of you today do banking on your internet, on your computers or even on your mobile phones. Okay, because of ICT, because ICT has enabled the bank to come to your device. So that is also a form of convergence. So that is where I've written some of the industries here, like education, healthcare, banking, business, government, science. These are only some. But actually, there is no area of life, not only business, but even in our social and personal everyday lives, nothing is untouched by ICT. Okay, so this is something that is critical, and it is something that is going to stay with us all along. And this is what has led to the digital revolution also. Any questions so far? I could like to discuss, but I'm not sure whether, because we lost a few minutes because of this technical hassle that we just had. But I would have liked to discuss, for example, take any of these industries, say banking or healthcare or any of them, and see how it used to be before ICT and how it is after ICT. So that would have made a more clearer impression about the impact of ICT on different industries. But I would like to give it to you as an exercise. Just if you can do that, how was banking before ICT? And how has banking, just let me give you a very, very, very simple example of how ICT has changed our life. Though many of you may not relate to it because you are very young people, but some of us like Dr. Mittal and myself can relate to it. For example, railway ticketing, how it used to be earlier. You had to go to the station, you had to stand in a queue, you had to fill up forms, and then you used to get a ticket. And now you can do it on your mobile phones. So that is nothing, the ticket is the same, your train journey is the same, but the process of getting the ticket has changed because of ICT, because of the impact of these 5 things that I've shown in the center of this diagram here. On the right, I talk about what is convergence, which we have already discussed. And we have talked about the definition of ICT just to re-emphasize it, but we have already covered it. So I hope the meaning of ICT is clear and how ICT is shaping different industries, different processes, different viewpoints, mindsets. Everything is changing because of ICT. And ultimately, it is ICT which has led to the digital revolution. Shall I move on? Okay, I'll move on. Ravi, can we go to the next slide, please?
Yeah, I am there.
Next slide, 1 second. So
the key milestones for ICT
key milestones. There are several key milestones. Okay, now here this is for the students. I would like to say we will be talking about some of these you may relate to, some of these you may not relate to, some of these you may find boring. That hey, why are we talking about this? This is not relevant. But please believe me, trust me when I say that this is all important in order to build a complete story, in order to have an end-to-end understanding of digital transformation, in order to understand the digital world and the digital workplace around you. It is important to know how it came about. So I will try to connect it all up. But please bear with me. The first thing to arrive, which was in the 1960s probably, was the mainframes. I do not know if all of you are familiar with the term mainframe, but a mainframe computers, they were very large systems which comprised of several discrete units. Discrete units, I mean like the central processing unit. It used to be a huge, you have seen steel almirahs. It was used to be like a steel almirah, which was its central processing unit. There were no microprocessors then. So there was central processing units, there was the console, there were user terminals, which were large terminals and tables set up in other rooms. There was tape storage, there was disk storage, there were line printers, and there were controllers. So all these came in the form of huge, when I say huge, I mean 8 feet tall and 3 feet wide, at least. Okay, so each of this, so our computer used to take up a huge room full of these racks in order to install one computer. And the power of that computer was less than the power of the small smartphone that you hold in your hands today. That is what Moore's law and other concepts have done to technology. So they were very large, but by today's standards, not very powerful. One thing about these systems was that they did not have very advanced storage facilities. They did not have very advanced display facilities. There was no graphics or anything. So therefore, all people could do was print. So there were all heavy emphasis on printing. Whenever you go to a computer center, you will find printers churning out reams of paper, printing after printing for 2 days continuously. They would keep printing. Okay, but technologically, the biggest challenge with mainframes was that they were proprietary. Each mainframe or each type of mainframe had its own operating system. Today, for example, you have operating systems like Android or iOS or Windows, where everybody, whether it is me or you or somebody sitting in Africa or somebody sitting in Finland or somebody sitting in Canada, we would all be using the same operating system, Windows. So therefore, if I have an application that I love and I want to share it with you, I can just send it to you and you can run it, or some data that I want to share with you. Earlier, it was not like that. Every system came with its own operating system. So there was no sharing of information between computers. Okay, so this was a major limitation. So, but mainframes was one of the things that ushered in the ICT revolution. That was the first thing. So therefore, it is important to understand mainframe. One of the key things which I have not actually listed here, but is very important to understand. One of the mainframes, first and the most, popular mainframes was known as IBM 360. Now, IBM 360 heralded one more very major, milestone of ICT, which we have not mentioned here, but it is very important, was the introduction of the integrated circuit or the IC. Before that, these big computers used to be made of discrete components like transistors, relays, and all those things, diodes, transistors, relays. There was no ICs. With IBM 360, it was for the first time that integrated circuits were used. So those integrated circuits were also, I would consider them, the introduction of the integrated circuits was a very key milestone in the ICT evolution. Imagine what would happen today if there were no integrated circuit. There would be no microprocessors, there would be no laptops, there would be no mobile phone, nothing. Everything is has integrated circuit built into it. Okay, I think Dr. Mittal may have talked about or will be talking about Moore's law to you. I will not go into it, but we don't have time for that. But
the Moore's law would explain to you how the IC revolution has, the integrated circuits have progressed over time. So that was the first thing that happened in the ICT domain. Next thing to happen was mini computers. Mini computers were also like mainframes, but they were smaller. And the major thing about mini computers were that they were based on rudimentary microprocessors, like 80286, it used to be called, it was from Intel. So they were more integrated circuit driven, but essentially they were the same except that they were smaller in size, which is known as a smaller footprint, and they were based on integrated circuits. But they also had non-portable data. Suppose there was a company, for example, Wipro used to make mini computers earlier. Now Wipro you would have heard of. Now Wipro had its own operating system. It was known as WDOS, Wipro Disk Operating System. Now, anybody who has a Wipro computer can use it, but anybody who doesn't have a Wipro computer will not be able to use the software that is running on one computer. So again, the issue was that the software was not portable. You could not transfer data from one computer to the other. Now, the major breakthrough that happened, that the next drawing here, was the IBM PC. Now, I'll have to go a little bit faster. The mainframe and mini computers had their limitations, as we talked about, as drivers of business growth. They were batch, okay, we will not go into terms, like they were batch processing systems. That means the data had to be entered somewhere else and fed into them. You cannot enter data and process it online like we do today. Okay, so they soon yielded to another exciting development in the early 1980s. This is where I entered the workforce. That was the arrival of the personal computer, or similarly the PC. I'm sure you've heard of the term PC. It was introduced by IBM, but it was later cloned by others. Now, the PC filled a very significant gap, and this is very important for you to understand. The PC filled a very significant, because it is relevant even today, because it heralded the use of computers by the end user. People like you, me, everybody could use it. Now, everybody could have a computer on their desk. Earlier, computers used to be part of something known as an IT department. Nobody outside the IT department used computers. With the PC, now there could be a computer on every desk, like we have today. So the PC was the first desktop system that could be used by anyone, not just IT department. But however, even PC was not very popular, would not have been very popular if you could not share data between PCs. There was no networking, so you could not just send an email or like we do today. What happened at around the same time when the PCs were introduced, a new operating system was introduced by Microsoft. That was the first time that Microsoft entered the world of computers. What was their first product by Microsoft? What is the first thing that made Microsoft, and because of which Microsoft is what it is today? It was a common operating system called MS-DOS, Microsoft Disk Operating System, which could be used across all over the world. If you have a PC, you could run it on MS-DOS. And what that meant is that if I have written a software application today, I could give it to you and you could run it on your PC. You could give it to your friend and they could run it on their PC. So basically, you could share information and data and applications with anybody in the world. Though it was the network was not there, so you had to use something known as a floppy disk. You have to save it on a floppy disk and give the floppy disk to your friend. And then you say, okay, here is a new piece of data, or here is a new game or an application. You can run it on your PC. So that is what was a very breakthrough about the Microsoft Disk Operating System, that it enabled the sharing of data and applications between computers. MS-DOS soon became a standard platform. In fact, there is another story which I would have liked to say why the IBM missed out and how MS-DOS became what it is today. If it was not for MS-DOS, nobody would have heard about Microsoft. So I hope that is clear. I'm talking about simple concepts. Now, even now, it is not that because MS-DOS happened or PCs happened, so computers became mainstream and the IT revolution came up. It did not. Next thing that arrived on the scene was the client-server architecture. Now, client-server architecture enabled two different things to communicate with each other. Computer A, computer B, or within a computer, a mainframe could communicate with its terminal. But that is we are not talking about mainframes here. A client-server architecture allowed two computers to communicate with each other. One became the server, one became the client. Server means where the processing is done. Now, suppose take an example of an email. Now, there's a client where you write an email and send it. It goes to the mail server. The mail server takes it and processes it. Okay, what is this? Okay, this is an email. What should I do with it? I should transfer. I should forward it. Whom should I forward it to? Okay, I should forward it to Dr. Ravi Mittal because that's what it is meant for. So like that, the mail server does the processing. The client does the request. So there are two devices in that. One is known as the client, one is known as the server. The server is where the processing happens. The client is where the request is placed. Now, a client is an application, a server is another application. They are typically on two different computers. So basically what the client-server architecture did is that it allowed two different computers or two different applications on two different computers to communicate with each other over a network. Okay, so basically, this was the first time that a concept of a network could be introduced in the business sense, not in the scientific sense. In the scientific sense, networks have been there for a long time, but in the business sense. So, and this realization that through using the client-server architecture by making one device a server and several other devices the client, that is the basis of the internet also today. The internet is nothing but a cluster of clients and servers. Okay, so this client-server architecture is what actually heralded the use of computers across and the use of networking. That is how, this is what led to networking, and because you could connect two different computers, one as a server, one as a client, and the server could communicate with its client. So that is where the concept of networking or connecting computers together started. Now, what was it that was done to connect computers together? You do not send a big piece of data in bulk to the other computers. You use something which is known as packet-based communication, or which is known as packet-based communication. This is an important concept. Remember, packet communication. Packet-based communication is what? Packet-based communication refers to, I'm saying it slowly so that you can understand it, refers to sending information in small units over different paths. Okay, and then reconstructing the units at the destination. For example, if I have 10 MB of information, I could break it up into 100 KB pieces. I'm just giving an example. It is not a real example. And they would arrive at the destination, and there they would be sequenced back together so that you see it exactly as it was sent. So that is what is packet-based communication. Again, to repeat, it is basically breaking the information into smaller packets or smaller pieces, and then sending each piece through a different path, and then reconstructing the small pieces together again at the destination. That is known as packet transfer. And the protocol that was used to do that, how do you send it? You can't follow your own system. You have a 100 KB packet, you have a 10 KB packet. So there was a standard. The standard is nothing but a protocol. The term standard is referred in telecom jargon more or less as a protocol. Now, there was a protocol that was used to do that, and that protocol was known as TCP/IP. I'm not going to go into the full form. Don't try to remember the full form of TCP/IP, which is Transport Control Protocol over Internet Protocol, but don't confuse yourself. Just remember TCP/IP. TCP/IP is an important term. TCP/IP became the lifeline of what we now know as the Internet, and is still used as the dominant protocol for Internet communication. The whole Internet communication is packet-based, and it happens using TCP/IP protocol. That's what is important for you to remember. Now I'm going to just skip over some of the things, because similarly, the networking and LAN, the concept of networking, people realize that you can grow the number of computers in a network by using certain standards and protocols for them to communicate between each other. This led to the evolution of the local area network. Local area networks allowed different computers within an office to communicate with each other, send messages, send emails to each other. This is what, so you have PCs, you are connecting them over LAN, and you are using packet-based communication, and you can communicate with each other. You don't have to record data in a floppy disk and then physically hand over the floppy disk to somebody else. Now, this realization is what led to the evolution of the internet. What is the internet? Now that we have heard about concepts like client-server architecture, we know what is a network, we know what is TCP/IP, so we can define the internet. Now, I'm just going to give one clear definition of the internet based on what we just talked about. So the internet is merely a vast network of clients and servers. Okay, again, let me repeat. The internet is merely a vast network of clients and servers which are communicating via packet transfer protocol. So we know what's a client, we know what's a server, we know what's a packet transfer protocol, which is nothing but TCP/IP for sharing information in the form of web pages, like, okay, using client-server architecture. So basically, this concept of client-server architecture, network, protocol, packet transfer protocol, TCP/IP is important to know to understand what is the internet. You are all technical people, so for you, that technical understanding of what constitutes the internet is critical. So the internet is a network of clients and servers communicating via packet transfer protocol like TCP/IP for sharing information using client-server architecture. This is the simple definition of the internet. So this then again led to World Wide Web. World Wide Web is, by the way, different from the internet. Internet is the communication medium. World Wide Web is the collection of information on the internet. It is a collection of websites or web pages which are identified by a URL. You all know what is a URL, a uniform resource locator. So it is an address basically for a web page using which you can you can communicate on the World Wide Web. So the World Wide Web happened. Then web browsers came. Sorry, Ravi, can we go to the next slide?
Yeah.
I want to change the slide. Okay, so we talked about the internet, then the World Wide Web. World Wide Web is the collection of web pages on the internet, and then we have the web browser. Because if there was no web browser, what would happen? You all know that, right? Because the text on the which is exchanged between computers on the internet is not in the form of what we see on the screen. It has got HTML. It has got metadata. It is basically formatted text which can only make sense to a computer. So the browser strips out all that and presents to you images and text in the form that you can see. Otherwise, it would be completely unintelligible to anybody. You won't be able to understand what it is. Plus, it enables certain programs and applets like to run. So a browser is like an interface between you and the data on the World Wide Web, which is not readable without a browser. So browser is unless a browser had happened, the internet revolution would not have happened. And if the internet revolution had not happened, the digital revolution would not have happened. So therefore, all these things, as I said initially, are critical. So we talked about internet, we talked about World Wide Web, we talked about web browser. We could go into more details of this, time permitting, but maybe in the rest of the lectures we will go through. If you have any questions, you can always come back to me. So then we have data networks. Data networks is also located as a form of a internet. Data network is different from the internet because an internet is a worldwide network. A data network could be within your own domain. But today we look at data networks also in the concept of mobile networks, in the concept of optical fiber cable networks. All this also contributed to the evolution of today's technological revolution that we see around us. So this data network is basically why I have brought it up as an important milestone, is that a data network is what is constituted of wireless data, wireline data, optical fiber, all of it coming to, even satellite, coming together to enable you to exchange information. If a data networks were not there, suppose you had a mobile phone but it was not connected to data, you would not be able to do e-commerce, or you would not be able to connect to the cloud. So these data networks are important. Internet is good, but if the internet only worked within certain pockets, it would have served no purpose. So data network is what has enabled you to use the internet anywhere, anytime. Okay, so that is what is the importance of data net. A data network typically could be the internet, it could be a subset of the internet also. But in either case, the concept is the same. A data network is what enables you to connect to the network irrespective of where you are, using different technologies. It could be 4G, 5G, 3G, it could be optical fiber, it could be cellular, it could be satellite, it could be phone line, it could be leased line. All these are the elements of the data network. Then you have a very important concept which I have written here on this slide at the lower right side, which is a web server. Why is a web server important? Now, a web server today, all of you have laptops, right? Now, and all of you have an internet connection. So any of you today, right now, today, by this evening, today, you could start your own company. Because all you need to do is a laptop, you configure it as a server, you connect to the internet, you write a Java program to start a new trend, to start a new business, because so this is lower than earlier. If I had to start a business, what did I have to do? I had to set up a factory or an office, or I have to get a lot of people working for me. I had to do a million things in order to set up a new business. Today, all you do is to have a laptop, connect to the internet, write a Java program, and you can say that, okay, I have started a company. Because at the core of it is an idea that you have. You have an idea, innovative idea. Okay, that I will do this. I have some very good examples of these such ideas that we could discuss. But you could convert that idea into a business by today evening. If you have the idea right now, by evening you have that idea converted into a business, and you are in business by tomorrow. Okay, so that is what is the role of the web server. A web server enables you to write a program logic, or even host a website, or host a portal, or host a web logic which instantly connects to the internet, and you can have a client base, a worldwide client base, because you have a website now, or you have an address at which people can connect with your business and exchange data, information, commerce, money, whatever with you. So web servers are important. Earlier, if web servers were not there, people would not be able to have e-commerce, or people would not be able to do any web-related services for users. Okay, everything, all the services like Amazon, Uber, Airbnb, Netflix, all of these basically are web servers running somewhere. Okay, and you are all clients. We are all clients of those services. So those web servers are important. It could be large, like an Azure or the AWS kind of a thing, or it could be as simple as your laptop. A web server is critical for the running applications on the web. Now, web mobile applications we all know about, because there are web servers web is a server, these web mobile applications are clients. So essentially, using our devices, we can access a lot of services on the web. All these are critical milestones in the evolution of ICT. That is the broader message here. Now here, again, one more thing that is very important that we should talk about in the next 5 minutes, I will close this entire slide, is the IPv6. How do you address them? With so many millions and billions of devices on the net, we have a problem that if I have to address you, for example, any of you of the students here, you give me an email address or you give me a web address. Now that web address translates into something known as an address, IP address. Each device on the internet is identified by something known as a unique IP address. Today we have an IP addressing system known as IPv4. IPv4 is a 32-bit addressing system. Ravi, we can go to the next slide. IPv4 is a 32-bit addressing system. Now, as you all know, digital technology is about ones and zeros, right? So 32-bit and each bit can have two states. So basically, you can have 2 raised to 32, which is 4.3 billion unique devices on the internet today. You understand? With 32-bit addressing, you can have 2 raised to 32 or 4.3 billion unique addresses in the world today, which means only 4.3 billion devices or things or people can communicate with each other. Now, that's not enough. Right, that's not enough because the world's population itself is now close to getting to be 8 billion. And then there are Internet of Things. So a lot of things are getting connected to the internet, like connected cars and stuff like that. So therefore, a new the addressing system had to be evolved. Now, many devices have already moved up to that, and many are still in the process of moving. But predominantly, we are still using IPv4. This new addressing system is known as IPv6. The older one was known as IPv4. IPv6 is a 128-bit, not 32-bit, but 128-bit addressing system. I will not go into the format of it. It is written here on the slide if you want to see. But we will save time by not going into it. But 128 bits means that you can have now 2 raised to 128. And you know how much that is? It is such a huge number that even if every particle in the known universe had its own IPv6 address, it would still be, we will be having billions left over. Every particle in the known universe, I'm not even talking about this planet. So it is so large. So with IPv6, we will never go out of addressing of uniquely being able to identify different devices. So this is, I'm sorry I have to go a little bit fast. We will talk about the final. So all this basically, there are other milestones also. I've only talked about some of the critical ones, some of the very critical ones. But there are many other milestones which I have not talked about. Maybe we will touch upon it in future. But these are, in my mind, these are some of the important milestones which led finally to the digital age, which is what we'll be talking about. By digital age, we mean new digital technologies like cloud or the enterprise mobility or big data analytics and social media and IoT and that kind of stuff. Okay, we'll talk about that. So basically, these are some of the important ICT milestones. All these things that we talked about are basically components of or elements of ICT, examples of ICT. In my view, these were the major milestones which led to the today's digital age. Without any of them missing, if any of them that had not happened, okay, we would not have the digital age today. Any of them, not several. Any one of them had been missed in the equation, you would not have the digital age today. Let's go to the next slide. This is an important slide, but I will not. So on the right of the slide, you see all the different milestones that we talked about. But this basically talks about the different generations of ICT. So it started with expensive mainframes that we talked about. In the next generation, after some time passed, we had mini computer systems with terminals and microprocessor-based systems came along. Then we had PCs and LAN and client-server architecture, which we talked about. The next generation, the fourth generation of ICT, as it is known as, was the internet, WAN, IT, telecom, web. All this happened. This was in the late 90s, I would say. Okay, this was the fourth generation of ICT, and now we are in the fifth generation of ICT, which is basically SOA. SOA we will not talk about right now, but cloud computing, Web 2.0, broadband, mobility, and all these other cloud-based cloud computing, big data analytics, streaming, and all this was part of the fifth generation of ICT. Now, all these 5 generations happened in a span of 70 years. If you look at sometime like late 50s or something as the start of the first computers when they were launched, 70 years later, we are in 5th generation. That means in one human span of 70 years, in one human generation, we have seen 5 different generations of ICT. Earlier, ICT was used only for automation. If you see at the bottom, IT for automation, it was only used for automation. There was no other use for IT other than automation. By automation, I mean things like, how shall I say? Let me think. For example, automating your bank computerization or automating your railway ticketing or ERP manufacturing processes. Then it was used as a tool for productivity, where you could use enhanced applications like word processing and other things to basically improve your personal productivity, because now you had a personal computer on your table. So you could use that to enhance your productivity. And finally, only now it is that now the ICT is used for promoting and growing business, which means that you have company intranet, self-care portals, e-commerce, unified communications, you have web-based services, payment gateways. All this has led to IT for business. So there are three major transition steps for ICT. First, it was used for automation. Then it was used for productivity. And finally, it is used for business. And when IT is used for business, when IT or technology, when ICT converges or intersects with business, what do you get? You get the digital revolution. The digital, how shall I say, the digital age is nothing but a convergence or an intersection of ICT with business. ICT and business have been merging together for many years. They have been coming closer and closer. And with each generation, okay, just one question I will ask here. If you could answer now or later, okay, what is the difference from, what is one common theme that is apparent from one generation of ICT to another generation of ICT throughout this diagram? I'll tell you what. With every new generation of ICT, the adoption rate of ICT, that means the number of people using it and benefiting from it, has increased. Earlier, when it was mainframe, it was only reserved to some scientific or secret organizations and institutions. Today, when it is the digital age, the fifth generation, everybody is using it. The auto rickshaw driver is using it. The company CEO is using it. Everybody is using it. Earlier, very few people were using ICT. Okay, so basically with every generation, the adoption rate has increased. That is why I have shown the growth as a cone. One dimension of it is time, of course. On the one vertical is the evolution, as new technologies evolved or they were created, and the other is how they were adopted. Okay, when I finish this slide, if I have time, I will tell you a story about adoption. Adoption means how people have accepted the technology, whether people are using it. There are many technologies that come up, but they are not used. Okay, so adoption is as important as evolution, because you can have the greatest of technologies developed, but if nobody is using it, there is no sense in the technology. So therefore, adoption is one of the most critical aspects of evolution of this ICT wave that we are seeing. So both adoption and evolution are important. Earlier, people were against computerization. People used to think of computers as something that would push them out of their jobs. If a computer can do it, what will happen? I mean, today also people worry, when artificial intelligence comes, what will happen to my job? No, but what happened ultimately? That fear was baseless, because when computers came, more jobs were created. It was not that jobs were lost. It was that jobs, the whole industry, the IT industry, software industry, all that happened as a result of adoption of ICT across the world. So if adoption had not happened, technology would be useless. It would be just locked up in a cupboard. So adoption, evolution, both have led to the growth and the different generations of ICT. Okay, we talked about the past of ICT. Now I'm on the next slide. We will not talk much about this today, but this is the future of ICT, the different new technologies like cloud computing, low Earth orbit satellites, IoT, machine-to-machine internet, artificial intelligence, machine learning, deep learning, software-defined everything. Software-defined everything means that now today, everything is differentiated by software. For example, if you look at routing on the internet, if you have to send a message from point A to point B, it is routed through different points. So you don't use routers now. You do not use dedicated routers. You use common servers or common computers which are there. Only the software that is running on it is called a routing software. So a common piece of hardware can be used as a router. It can be used as a server. It can be used as an application. It can be used as anything. So basically the hardware is getting standard. It is the software that is now defining everything. Okay, so this is the broad concept of the software-defined everything. Blockchain, we will probably touch upon it if we can in a later session. Robotics and quantum computing, merged reality. These are all the future aspects of ICT. We talked about the past aspects. We talked about where we are today, and we will be talking more about it in the next session. And then we talked about where we will be in the future. There are 5 things. This is the last slide, and I think we are just on time because we have what? We are. Okay, basically, it's the 5 things that have led to the new environment, which is the digital environment, there are 5 things. And remember these 5 things. Remember these 5 things. These are very important. You may be required to discuss it in your interviews, or you may be required to use it in your work life very soon. But this is something that has to be on the back of your mind. One is the explosion of mobile data. If these had not happened, and these are all ICT-driven trends. Okay, so one is the explosion of mobile data. You see the amount of data around you today. Just think about it. It's mind-boggling. Abundance of bandwidth. You have today, whether you are, even if you are outside on the road, you have abundant bandwidth to be able to download a file instantly if you want it. So, and of course, at home you have Wi-Fi, so you have a lot of bandwidth. Abundance of bandwidth, amalgamation of IP-centric technology. Again, we go back to the concept of web servers, where you can develop an IP, you can develop applications which can communicate over an IP network. Okay, or IP-centric technologies. Those are also coming together. Basically, the IP networks and software are coming together to create web services. That is what has led to this new environment. Then proliferation of smart devices. Suppose all this was there, but people did not have devices. Nothing would have worked. But the good thing is that everybody, whether it's a school student or it is some president of a country, everybody has mobile devices. Everybody has laptops, or if not laptop, at least a mobile device. Everybody has. So this proliferation of smart mobile devices has driven it. And finally, most importantly, people have hunger for information. You want to know more. You want to see something. You want to access something. So there's a growing hunger for actionable information anywhere and anytime. And all these 5 things coming together have led to the digital ecosystem. How you transform from where you are and become a part of this digital ecosystem, we will be discussing over the next few classes. Okay, so this is what I had. And before I leave, I know the time is up now. We are at exactly 11:30. So there are a quick few questions. If you have been able to appreciate what we discussed in this class, you should be able to answer these questions in a minute. Like, what are the main factors behind the adoption of personal computers or PCs? Why did they become? So what I would suggest is you look at these questions, and if you can and if you want to, please give me. And all these questions may not have a right or wrong answer. It could be your opinion also. You can always share it with me. Right now, I'm sharing my personal mail. But once I have an IIT mail, I will share that with you, and you can. And any other questions also. I know that we had to breeze through this session very, very fast, so I could not stop for questions or comments. I wanted to share some stories also, which we could not. But in case you want any to share anything or ask anything that you have not grasped, please feel always free to write me a mail. My mail address is given on the slide. Ravi, I'm talking about slide number 10, please.
Okay.
Okay, so these are some of the questions. Even if you cannot answer and send it to me, just go through these questions whenever you have time today and see whether you can answer these questions. Because if you can, that means you have been able to grasp many of the things that we discussed today. So that's all I would say. Thank you.
Thanks, Ashish. And folks, what we are doing right now is that we are starting with basic concepts of digital technology, and later on, last part of the second half of the this course, we will be discussing largely about how you can use this technology to transform a business. I mean, you can think of any business.
That is the intent. This was just a foundation.
Yes. So you may know, for example, we will give you exercises as a project. You'll have to think through what technologies you are going to use. Of course, it will be ICT, a combination of both computing and communication. And how can you transform a business? Say, for example, a pan shop, right? Pan bida shop. The guy is there. I mean, but the guy has to transform his business sooner or later, right, to remain relevant. Or there is a small kirana shop. They also have to transform. Otherwise, they will be out of business. They'll be eaten up by, say Amazon or whatever. So we'll come to that little later.
Yeah, we will come to that. Those are very relevant and important points, Ravi, and that is exactly what we are going towards. In fact, this is what is the whole purpose of this thing, that you can relate any business to a. That is what Ravi just gave an example. The pawn shop is a good example. Even a pawn shop can digitally transform itself and become a digital enterprise. That's what we will talk about. We'll talk about digital enterprises and see some examples of it. And it will be very good to do an exercise which you can all, all the students together, to come up with ideas, and you'll find that you're so full of ideas, and those ideas will find a avenue to come out and create new business models, new technology models, and that is what this digital transformation is about. It unlocks your mind totally. These are just some of the building blocks that we talked about today. We are going to talk about its applications later. All right.
All right, folks. Thank you very much.
Thank you.
Thank you. Bye-bye. Bye.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.